For almost a century, the petrol-powered engine has changed our lives in a way that few other devices have. It's allowed us to travel and explore the furthest corners of our world in great comfort and luxury. In the UK, there are now over 30 million cars, but due to environmental concerns, the way we fuel the car will soon need to change. My name is Darren Ould, and I'm on a journey to find out whether hydrogen could be the next fuel source for the car, and if it is, when we might be using it. The idea of using hydrogen as a fuel source is certainly not a new one. It was Welsh physicist William Grove in 1839 who first devised the concept of the fuel cell with the gas battery fuel cell. The concept of the fuel cell had not caught on though until 1932 when Francis Thomas Bacon demonstrated his hydrogen oxygen cell using alkaline electrolytes and nickel electrodes. A lot has changed since these early forms of fuel cells though, with fuel cells now having a proven track record in space missions and now in the automotive industry. Well, a fuel cell is a device that generates electricity by an electrochemical reaction. The fuel cell works on the same basic principles as a battery, except that the fuel needs to be fed to the electrodes and not stored in electrode materials. This is where our first problem is encountered if hydrogen was ever to be used as a fuel source. Unlike in your car now, where the fuel is stored as a liquid in a tank under the car, hydrogen being a gas at room temperature means that it must be compressed or liquefied to store it in a manageable volume. If hydrogen was to be compressed, then the tank must be strong enough to withstand the high pressures needed. If it was liquefied, then it must be kept very cold, below -253 degrees Celsius. The few cars that have currently started developing hydrogen fuel cell technology use a compressed hydrogen storage tank with pressures of approximately 70 megapascals. A stream of hydrogen will flow to the anode. Here the hydrogen undergoes oxidation, forming 2 protons and 2 electrons. The H+ ions travel through the membrane to the cathode. The key point about the membrane is that only H+ ions may travel through it. It does not allow electrons or hydrogen to pass through. The membrane itself is made from naphthalene, which is a sulfonated tetrafluoroethylene-based fluoropolymer copolymer. Its structure is shown here. It is made by DuPont and strengthened by Gore-Tex. It is the SO2OH sulfonic acid group that only allows for the passage of H+ ions. At the cathode, the H+ ions that have just passed through the membrane react with a stream of oxygen to form water. Meanwhile, whilst this is taking place, the electrons produced by the oxidation of hydrogen travel around the external circuit. It is this flow of electrons that produces an electrical current. A big question we have not yet addressed is how do you form hydrogen in the first place? Well, the first way is through the electrolysis of water. This is the process of decomposing water into its constituent elements, hydrogen and oxygen, by passing electrical current through water. This is potentially very expensive unless cheap sources of electricity can be found, such as through using solar energy or wind turbines. The second approach is through a reforming reaction. This is where hydrogen-rich sources, such as methane, are reacted with steam to produce hydrogen and carbon monoxide. The carbon monoxide would then need to be removed. Coming up with a way of forming cheap hydrogen is therefore a must if hydrogen fuel technology is ever to replace fossil fuels. Furthermore, the produced hydrogen then needs to be distributed. Hydrogen may be distributed by pipeline, much like oil is today. There are safety implications with this though, as the hydrogen will need to be in a compressed state. Hydrogen flows from the storage tanks at the back of the car to the hydrogen fuel cell stack. This generates electricity. The electrical current flows to the boost converter, which increases the voltage of the drive motor and in turn reduces the number of fuel cells needed. The power control unit can then convert DC current to AC current, which is then fed to the electrical motor. This motor converts electrical energy into mechanical energy and drives the wheels. The only waste product formed is water. The car could be refueled in much the same fashion as it is today. You would simply pull into a hydrogen filling station and fill the car with a stream of compressed hydrogen. A question at the start of this video was whether hydrogen could be used as a fuel source to power the car, and the answer to that is it already is. Hydrogen fuel cell technology is already being used to power some buses in large cities across Europe. Furthermore, the Toyota Mirai mean in future in Japanese, is a hydrogen fuel cell powered car that goes on sale in Japan this year and arrives in Europe and North America next year. The problem with fuel cells is not that the technology isn't ready, but that the investment isn't there to make this technology cheaper and develop the infrastructure required. Until the investment is there, it is unlikely that we'll be fueling our cars with hydrogen anytime soon.